Hello and welcome to today's Voltha TST call, and thanks for joining. First topic of the agenda is that we are in the process of upgrading to Helm 3 and Kubernetes 1.18. As of today, we merged a patch on kind Voltha, which you can see here, that introduces the capability and the support for Helm 3 and Kubernetes 1.18 to kind 0.8.1. But that is not yet turned on. So if you want to try it out, you export these two variables, and that moves you over to Helm 3 and Kubernetes 1.18.1. We have tested this and we know it works. And if the compatibility between this Helm version and 1.15 Kubernetes will be proven to work in some final tests that I'm doing and Matteo did yesterday. We will have that as default. We will still keep 0.5.1 as kind version for 1.15 Kubernetes until the ONF pods have been moved to Kubernetes 1.18. I'll leave David and Theo, if you guys have any comments, to the floor to you.
I don't have anything.
No, not really. I tried it yesterday with Helm 3 and Kubernetes 1.15 on a kind cluster, and it seems to work. I wanted to make at least one run against the physical pod just to be completely sure, but I don't see any reason why it shouldn't work. Just since all of our test pod are on 1.15, I'd rather be super sure than break the entire testing infrastructure. And also there is a plan to migrate the test pod to Kubernetes 1.18, but that is going to take a little while.
Okay, thanks Theo, thanks David. Any questions, comments on this?
So even if we get the master of kind Voltha, we still need to set those environment variable, right?
Yes. At the moment, the master is still on Helm 2 and Kubernetes 1.15. But if you set those, it just re-downloads a newer version of kind, 0.8.1, and reinstalls Helm for you, and it's all newer versions from there.
Okay, cool, thanks.
I've been using it in my workflow today in a couple of other patches that I'm working on, so works perfectly fine. Okay. If nothing else, I'll go on the next topic. So the next topic is something that I put in there, and it's related to something that came up in the device management interface brigade call, which is the logging of the components that sit on the OLT box. So in device management interface call, we're particularly talking about things like the operating system and other components that do not pertain to the data path. And we were considering what is the best option for the device management interface to configure logging on the device. The requirement came because the operator would like the capability to the device manager of setting the log on a specific device to a specific level for a specific component. But the question that many of us had on that call is what level of abstraction is the correct one to provide to the operator, And there are kind of three options there, and some of you were in the set of discussions, so please feel free to intervene and fill some details. So one is to define an API that holds both an enumeration of log levels, such as info, warning, debug, and things like that, and a set of predefined components that the log can be set to. For example, the operating system, for example, other type of elements that are on the box, other type of software that is on the box. And this is the most restrictive one because in the protobuf of the API, you will define the level of the logs and the components that you can set it to. This can easily spiral out of control with too many log levels and too many components. The upside of this is that the NEM layer that controls the device manager just needs to know about that API. The middle ground option is to have an API that defines the enumeration of the different level of the logging, info, warning, etc., but passes the component that such level is set to as a string. And that means that the NEM has to have knowledge of specific elements that are on the device. The third one is a pass-through API. Just set log, a level which is a string, and a component which is a string. And that's about it. The third one is less restrictive, but it imposes the NEM layer to have a lot of knowledge about exactly what he's setting on which device. And that's part of the discussion of, well, if we go with option 3, is the API really needed? NEM could just go directly to the box. Before I go forward, is there any questions? Because really what we are looking for here is feedback on what is the best way forward for many, for deployments of many different type of devices that have different set of components on the box that need the log to be configured.
So is the essential problem here that different boxes will have different sets of log levels and we can't assume a consistent info, warning, debug applies to all devices?
Yes, indeed.
Then it seems like your only choice in that case would be to expose them via generic API that took a string.
Yes, the
Your
point
option
is,
number 2.
Yes. Well, yes and no. That is the requirement, meaning supporting many different type of boxes. How we support them is our choice. Because if we say you do the mapping, this is the 5 log levels and 10, 15 components that you can set the log level to, and you do the mapping. We don't care. That's it. That could be an option. But yes, the issue is abstracting the log setting capability.
So if a device had finer granularity, if it supported 6 log levels, yet our API only supported 5, then we would just limit the granularity down to 5. Let's say it supported both trace and debug, we would just map that to a log level and it would be debug and you would get both trace and debug. If that makes any sense.
That makes sense to me. And the most restrictive one is the one I would go for, because that saves the operator NEM a lot of complexity, which is the whole point of the level of abstractions that we were putting in place here. But there were some comments on the device management interface call, especially from the people that are actually implementing this, namely Holger from Altram, that would be very restrictive on their capability. The counter argument is that this is a generic API, and if something is really, really, really screwed up, you could go directly to the box and do things. Just manually.
Yeah, I kind of like your point in favor of simplicity, and that our job, at least in Volta, has been to create abstractions that simplify rather than exposing every single detail through. Though the escape hatch could be a little bit worrisome in that you go directly to the device and set something, and then device management comes along and via the more abstract API and resets it back. That you know that you have a competition for who's in charge of that log level. But yeah, I think the traditional set of log levels, info warn, debug, error, those seem standard within software development, that one would hope you could fit whatever needs to be done under those and not have to deal directly with a bunch of device idiosyncrasies. So what do you, this would also have a similar ability to confine levels based on package, like has been done recently in Volta. You know, you could set a debug on a certain part of a component, whereas you set info on other parts. I mean, that's sort of an additional way to get a little bit more granularity on certain parts, so that you're not upping the noise level for everything.
So that is the second option. And that also reminds me that there was another proposal from David that where he wanted to basically have two APIs. One that says, okay, give me your logging capabilities and let me do the setting based on the capabilities you give me. It's a lot more convoluted, but it does enable you to do whatever you want on the different type of boxes.
Is there a fourth option here too, which is basically say, look, if you want to set the login on the device, go to device and do it, and it's outside of Volta?
Yes, this is this one, which we could be fine with. Is just that logging was brought into the picture for device management because NEM, if this option is chosen to go directly to the box, then NEM would have to know a lot of things for the boxes that are currently in the process of getting abstracted through the device manager API.
Or it wouldn't go through NEM. They'd just have an operator go to the box and set it. What other hardware in the environment are we setting logging on, right?
No, this is just for the OLT. For now, let's forget everything else. The device management API an interface is just for the OLT. This was
Right, but
we decided
understood.
that.
But there's lots of other hardware in the environment, the aggregation routers and switches. We're not setting logging on that, and we're not even thinking about setting logging on that. So
No.
why would we treat the OLT different here?
That is because the other one is not a key element, meaning that you could deploy a Volta stack without an aggregation switch and managing the aggregation switch completely out of band in some other way that Volta doesn't care about. But the OLT, you cannot deploy the OLT without a Volta stack. So the minimum viable product for Volta as a system includes logging of the OLT. At least this is my opinion. And anybody who has another one, I'm more than happy to hear it.
At one point of time, I believe like we're talking about having some kind of EMS that will be controlling those devices, right? Is that still in the picture?
So how one implements control over his devices underneath the device management API is out of the scope. Meaning that if, let's take the Adtran case, Adtran has their own NMS that then manages their own devices, and that exposes the device management interface API, that's perfectly fine by us. We don't see it. The whole point is that NEM interacts with the device management API, and that's it.
Then shouldn't it be logging be in a realm of that EMS kind of software instead of NEM?
Yeah, I think it is. I mean, what Andrea is asking is that from the NEM, you should at least have the ability to set the logs on the OLT device, right? How you do it is up to the adapter for the device management interface, right? So that could be the EMS for that particular box from that particular vendor. So how they actually set it is up to that EMS. But from an operator's point of view, you want to still use the same common device management API. And then, to set the log level, and then however they want to do it, it's up to the EMS, right? There's one common API for setting the log level, regardless of which vendor, which EMS from which vendor, and how that EMS is doing it in that box. So what Andrea is asking is, if you want to make logging part of this common API that the NEM layer can use, at what granularity should that common API be able to set log levels? And my vote is always for the simplest one, right?
So option one, sort of this one.
Yeah. You don't want to know everything that's running inside the box, and then what levels it can handle, and then be able to set that level. I mean, it's fine for us to do it in Voltha, because it's very useful in Voltha to have, be able to turn off, to be able to set the log level on, even in a sub component in libraries that are used in that component. So it's fine from, especially from a developer perspective, to be able to, who's already aware of that in a component there are, say these different things that make up, different libraries that make up that component, so I can turn on and off logging at a certain level. It's fine for Voltha to have that complexity. But in this device management interface, my vote is still for the simple one. Was that the same as yours, Andrea?
Yes, it is. My vote is for that one. It was just that I would have enforced this on the device management interface, but there were enough, how can you say, there was enough discussion to yield a bigger one in the TST place. And I would like to hear also some operator, if possible, somebody that has knowledge about what it's currently maybe done in existing systems, share some thought. And also, what are the operator requirements? Or are the operator interested in very fine-grained tuning of the logging, or is it a higher level 10-15 component good enough for them?
So I don't see Bjorn on the call. Normally I ask Bjorn whenever I have a question about traditional networking equipment, traditional OLTs, how do you do it there? but I don't see him on the call. And maybe Andrea, you can reach out to Bjorn, and maybe even Jamil, and ask them, what are their expectations? What do they do today?
Okay, yeah, we'll do.
Yeah.
Keep it. Does anybody have another opinion about this? You heard my opinion. You heard Seraph's vote. Anybody else?
How about the components that will be in that APIs? Are those just the common generic components?
Yes, that would be my thinking. For example, if you have I would just call operating system, just like at that point in the open source software, you will set it you will set the log level of ONL, and then you could have for example, BAL, and you could set the log level of BAL, or you could set the log level of some other APIs in there. The dev management daemon, for example, you could set that one there.
But they're going to have different, each device potentially from a different vendor has a different set of components.
Yeah,
It's not necessarily a single unifying component set.
Yes, the list could be debated, but for example, the operating system is the operating system, and you could call it a chip API, and that would be the dev management daemon in the upstream. Things like that.
And if there's a new device that comes in play that has a component name that is very similar to a component name that we are using, but it means something else, then we don't care, right?
The mapping is done internally in their implementation of the device management interface API. That's how we do it. That's how we do it in Voltha. With for example, the OpenOLT agent that takes in a standard northbound gRPC that we defined in protobuf, and it talks to whatever components underneath in whatever call it needs to be done, and does the translation. That would be my pick.
Okay.
Maybe Andre, after you ask to Jamil and Bjorn and get the requirements, we may not need this component, perhaps. I mean, we can only set and say that let's set the log level to something and pass this to the device only without any component.
Well, that was going directly to the box element, which somewhat does not abstract to them.
I mean, no, I'm saying that only getting rid of this component, it makes things it brings some kind of complication according to me. So if the operators, I mean, doesn't have any requirements about this, I think we don't have to do it.
Oh yeah,
it's
absolutely.
better not to do it.
Yeah, absolutely. If both Bjorn and Manuel and Jamil and Manuel and the others tell me that they go directly to the box, well, I'm gonna just skip it. It's less.
No, I think he's talking something else. He's saying rather than have component breakdown on the box, you just set a single log level on the box.
Yeah.
Oh, is that what? Yeah, is that what you're saying, Mahir?
Yeah.
That would be even better.
Mm-hmm.
Okay. Perfect. I
have a question. I heard a lot going directly to the box, but how does that play with box that are managed in band? Because in that case, we'll have to go through Voltha anyway.
Not really, because the in-band management interface gets an IP, and you could serve multiple things to that IP. It doesn't
Yeah, I mean, you can
have-
SSH into the box if you
Yeah,
wanted to.
exactly.
At the same time, while the gRPC communication is going on between Volta and the box.
Okay.
How are these boxes getting their default log level too? So if you look at the Volta components, they potentially look up a preset, if you will, in etcd as to what it was last set. So if a component restarts, it can go back to the right log level. Any thoughts on how this is going to work with the device itself?
I have not really given some thought to that. It depends also on the device management interface implementation to ensure that the log you set is the log that is actually on the device. I don't know. Okay. One more thing on the logging topic is how do we treat the OpenOLT process that is currently sitting on the box, at least in the open source upstream version of Volta. There are two questions there. One is who is responsible for the OpenOLT log setting? Meaning that is that OpenOLT agent just one of the other components that are present in this API that we have here? Or is that a completely separate piece for which we have another API that sets the log level just for that one?
So my vote is that it's just one of the components that are already in that API. We don't have to special case it. That's my vote.
That would be mine too, but I would like to hear Girish and others what their thoughts are.
Yeah, I agree with you and Sarah.
Anybody else?
Because when you think about it, there's not, it's not just the OpenOLT agent. There's also the daemon that runs over there. What do we call it, Girish?
Device management daemon.
Yeah, dev management daemon that goes with it. That does that control the BAL settings?
Yeah, that. Sorry, I didn't quite get your question.
I mean, that's the part that actually talks to the BAL API, or
the device management daemon is the BAL process.
Right.
The OpenOLT agent talks to the device management daemon.
Exactly right. So just one setting for both of, if they choose not to do it on a per component level, right? Just one setting for both of them is fine, right? When you want to see debug logs for OpenOLT agent, you at the same time want to see debug logs for BAL API, the BAL process.
Yes.
Yep. That sounds good to me. Okay. So I'll make sure to reach out to Bjorn and Samil and see what they tell me. What is the best option for them? I'll report it to the device management interface brigade call. We'll come up with a proposal and most likely put it already in the protobuf of that API, and I'll make sure to report to the TST any findings that we have. Will that work?
Sounds good.
Perfect.
Yes, also.
Okay. Okay, next up, I added this for the static application security testing. This is a topic that came from Deutsche Telekom and Reply. I was hoping for Andrei from Reply to be joining the TST, but I don't see him on the call, so I can maybe postpone this. But this is just, you can read through what the Jira is. Long story short is doing some security scans over the code more than what we do right now. We do static code check analysis for linting and things like that already. This is just adding a few tools to that check to have a better security check of the code of Voltha. Any questions?
So there's no one from Reply on the call?
Currently not.
Okay. Is anyone on the TST aware of this particular Jira story?
No. Good.
Okay. Well, maybe a couple of action items that we can take is we can talk about this in the next TST meeting. Hopefully, someone from Reply will be there. In the meantime, the TST can take a look at this particular Jira item. And because it needs to be part of the CI/CD pipeline, also make Zach aware of it and get his thoughts on that.
So the way I suggested that when first I got reached out about this topic is that if they want to go through with this, my suggestion would be to Dockerize the software as we have done for the linting and static checking and everything like that, and just upload the Docker file into the existing Voltha CI tools repo, Voltha tools repo. And that will publish the image, and then we would have to update the make files. But I'll add Zach to this, and I'll make sure that we get in sync on what needs to be done.
I think your proposal makes sense, Andrea, because all the other tools are containerized, so I don't see why this one should be different.
Yeah, but just just get feedback from Zach. He's he's now on a different project, but he can still give some advice.
Sounds good to me.
And meanwhile, I request the TST to take a look at this particular Jira, and then we can revisit it in the next TST call. Hopefully someone from Reply will be there.
Just a quick look, seems like there's some overlap with some of the SEA that we were already doing on it. It may do more than that, but there is some overlap.
Okay, I'll make sure to reach out to the folks that Reply and make sure they join next time. I was told that they would be today here, but apparently that is not the case. So I'll make sure they join next time to bring up and discuss this proposal. Please do take a look at it, and it's there. Okay. Before we go to the Jira update, are there any other topics that you guys want to cover? No? Okay. Surf, do you want to take control for the Jira update?
Yeah, thanks.
Okay.
Okay, so hopefully you can see my screen. So as you can see, we have a new version number on Jira right now, Volta 2.5. 2.4 still exists, of course. Normally, we would be ready to release 2.4 right now, but we are going through the Kubernetes and Helm upgrade, so we're working through the remaining issues for that upgrade, as Andrea pointed out at the beginning of this call. But what is now interesting is that we have Volta 2.5, and we have some stories that I have moved from the future version into Volta 2.5. It's meant for MVP 2.0 tasks, but I haven't moved everything. I'm hoping that the people on this call, people in the community, can start moving stories into the 2.5 version, especially, I have taken the liberty of moving things that were in progress. So there are logging things in progress, but there's a number of other stories for logging that are still sitting in future. So the Infosys folks working on logging, hopefully you can move your stories over there. Same with Val migration. We still have some issues with bandwidth, bandwidth shaping, metering in the Val version that we are going to release Volta 2.4 with. So there's still work required to fix bugs in Val. Test automation, there's always going to be stories. There's a number of things that we've gotten done in 2.4, but many more still to do in as we go along. Similarly, I've taken the liberty of moving some things, some maintenance tasks in there. There's going to be scale work, of course, some work on alarms and events. In-band work is mostly done. I think this is probably a bug, not a story. But I don't think there's a lot more work left in-band. Neither is there a lot more work left in multicast and multi-tcont. It's just a small feature that we need to get through. Continuing work in Helm charts and other things that will, of course, go beyond the upgrade work that we're doing right now. We're not doing anything specific about diagnostics and troubleshooting in 2.5. If necessary, we can start moving in, but one of the big features that we hope to enable in 2.5 is multiple NNI port support, with the inclusion of lags, link aggregation groups. So multiple NNIs are then linked into one link aggregation group, and they both go to, the lag is maintained with the aggregation switch side as well, right? So that's work that we hope to accomplish in Volta 2.5. A couple of weeks ago, you heard from NTT about supporting EPON, and that would mean, I think we concluded that a different adapter makes most sense in that particular case. So that's also work that will continue in 2.5. Security, I think we will need to explore. I don't see the SCA issue over here, the Jira item, but we need to move that in here. And also we need to think about how to secure the OLT adapter to OLT device communications. So we need to look at some best practices of in Kubernetes for securing external APIs. Software upgrade, there is work for OLT software upgrade that comes through the device management interface, but also when Voltha is concerned, we can do ONU software upgrade. And so there is some exploration. This was a feature that was there a long time ago in the old version of Voltha. There is some work ongoing to bring those features into Voltha 2.x. For now, in the Python version of the OpenONU adapter, but down the road in the Golang version as well, right? So that's the work that is going on for the Golang conversion of the OpenONU adapter, as well as the sort of the OMCI work. So
I think more stuff will go in here, Seraph. These are just 3 that are in progress, but there's going to be a lot more work.
Yeah, that's what I'm trying to get at. That I've only taken the liberty of moving a few items into Voltha 2.5 from the future. And everything that was in progress, I have moved it. But I'm leaving it to the people who are actually doing the work, or the brigade leads, to take a closer look and move more stories into 2.5. We also want to, there's the transaction model work as well as the core cleanup work. Again, Ken and Kent can take a look to try and move more stories into 2.5. There are some improvements, especially with Mac learning, that we want to target in 2.5. Currently in the telecom workflow, we are statically configuring in SADIS the MAC address of the RG or any devices that sit behind the RG, but that's not a feasible approach in in production. In production, we really do need to learn the MAC addresses of RG or any CPEs sitting behind the RG, and then program flows using a match on the learned MAC address. So that's work that's going on. The meter store in ONOS needs some improvements as well, especially in HA scenarios. So that's work that's also going to happen in the 2.5 timeframe. For scalability, there is work that is going on. Well, there's two main things that are going on. That's in the scalability brigade, there is work for multiple Voltha stacks. And also, we are going to start, we're designing it currently, but we're going to start doing some server sizing experiments to understand, just how much CPU and memory resources we are consuming for a single OLT that is fully populated with 1,000 or 1,000 ONUs. So that server sizing work was actually show up under the scale and performance tasks. Maybe it already does. I think I may have created one story over here to design such a matrix of measurements that can help us get the data for understanding what our consumption is for a single OLT. And in the meantime, of course, the multiple stacks work will also go on. And then there's, of course, work going on for the device management interface in the device management interface brigade. That will also include OLT software upgrades. Okay, so these, in a nutshell, are the various epics that we have targeted in 2.5. And we the end of the release date actually is the end of September. But we're going to do some things differently this time. Typically, what we have done is that we have meant this release date, for example, to be the date where we actually do the code freeze. And when we do the code freeze, that's when we tag and branch all the components. We start including that specific regression testing jobs in our regression, nightly regression tests. Then we go through and fix any bugs that we find. So we typically go through a 2, sometimes 3 weeks QA cycle, which means that the actual release is typically 2 to 3 weeks after the date that we use for cutoff. But we're going to change that for the next release, which means that we'll actually do the release on the date that we have specified, which is the quarter end. It does, however, mean that the cutoff date, the code freeze date, is going to be 2-3 weeks prior to this date. So around September 10th or September, sometime around that date. So that's a change that we are going to make for Volta 2.5. It does mean that Volta 2.5 will only see, a little over 2 months of actual work that goes in before the code freeze. Okay, so I just wanted to make everyone aware of that. But right now, please take a look at these epics, and wherever you are working, please ensure that you move stories that were in future into Volta 2.5. Any questions? Okay, thank you. Back to you, Andrea.
Thanks, Surf. That concluded the topics we had on the agenda. Does anybody have anything else that they want to bring up to the team? Then if not, thanks everybody for joining. I'll give people exactly 6 minutes back of their day, and I'll see you on Slack, and let's keep chatting over there for anything. Thanks for the great work as usual, and let's meet next week. Cheers, everybody. Take care. Bye-bye.
Bye, guys.
Bye. Yeah.
Bye.